Okay, what's going on, folks? Start off this lesson, we're going to take some notes on um, speed, speed of a wave. So what is speed? Well, the definition is just how fast something goes. Symbol for speed is just an S. And then the units, we measure speed in meters per second. So go ahead and fill this out on your table. Frequency, that's the number of waves that get made in 1 second. Right, so if we go back to our wave oscillator, let's go no end. Right, well, if I up the frequency, you can see it's making more waves. So frequency is the number of waves made in 1 second. Symbol for frequency is F, right? Pretty straightforward. Speed is S, frequency is F. Units, we measure frequency in hertz, Hz. Now a hertz is just 1/second, right? So that's why we say when we look at the definition, frequency is the number of waves made per second. That's why we measure it in hertz, is it's 1 per second. So for example, if you had a frequency of 2, that means you're making 2 waves per second. If you had a frequency of 10, you're making 10 waves per second. So hopefully that makes sense. Wavelength, that's the distance from crest to crest. So remember, the crest is the top of the wave, so if you measure the distance from the top to the top, that's the wavelength. It could also be from trough to trough, though, remember, so if you could also measure from the bottom. So from trough to trough, that's also the wavelength. Symbol for wavelength is this Greek letter. This is called lambda. And so you can kind of think of it as it looks like it looks like an A, but without the cross in between, and there's kind of like a little, I don't know, like a little tail at the top here. Is a good way to think about making it. Units for wavelength is in meters, right? We measure our distances in meters in science. Okay, so I'm going to teach you a little mnemonic device here to help you figure out which equation you should use to solve when you're doing wave speed problems. And so at the top of this triangle, I want you to write an S for speed. On the bottom left, I want you to write an F for frequency. And on the bottom right, I want you to write a lambda for wavelength. Okay. And so then let's make some equations using this triangle. Whoops. If we cover up the S, we should see that that leaves us with F and lambda. Whenever you have 2 at the bottom of one of these triangles, it's always multiplication. So S equals F times lambda. Similarly, so now I'm going to cover up frequency. If you have 1 on top and 1 on bottom, you're going to divide. So F, which is the one that's covered up, equals S divided by lambda. Whoops. And then lastly, if we cover up lambda, we'll see that lambda equals S divided by F. And so these are the 3 equations, so you're going to want to write these equations down. These are the 3 equations that we're going to be using to solve for speed in this lesson. So speed equals frequency times wavelength. Frequency equals speed divided by wavelength. Wavelength equals speed divided by frequency. And we'll go back over how to use this triangle to figure out which equation you're looking at. You could also do this just with algebra. If you know the first equation, you can get the rest of them. Okay. So, example number 1. What is the speed of a wave that has a frequency of 30 hertz and a length of 10 meters? So, step 1 for these problems is going to be to identify the variables. We don't know the speed because they're asking what is the speed. So the speed is unknown, so you're just going to write a question mark there. The frequency is 30 hertz, so you're going to write 30 hertz for your frequency. The length of the wave is 10 meters, so we're going to write 10 next to lambda for our wavelength. Next, we're going to write the formula. Again, we're looking for speed. Speed is our unknown. So we're going to take this equation right here and we're going to cover up speed. So we're going to take the triangle and we're going to cover up speed. And that leaves us with frequency and wavelength. So that lets us know, since those two are on bottom, that speed equals frequency times wavelength. So then we'll write that in as our formula. Speed equals frequency times wavelength. Okay, so then I'm going to rewrite that at the top of step 3, and then we're going to plug in our numbers. We don't know S. F is 30, right from right here. Lambda is 10. So we'll plug that in. 30 for F, 10 for lambda. Then we're going to multiply 30 times 10. You can use a calculator. In fact, I'll do that just to model what I want you to do. So 30 times 10 gets us to 300. So S equals 300. Step 4 is just to write the answer with units. So we're going to say S equals 300, and then it's meters per second. And that's because S is in meters per second. And we should have written that down in the table. So look at your table if you're unsure what the units are ever. The one at the very top of this assignment. Okay, let's do a couple more examples. What is the wavelength of a wave that has a speed of 125 meters per second and a frequency of 25 hertz? Well, our speed is 125 meters per second. Right? It says it right in the problem. Our frequency is 25 hertz. Again, says that right in the problem. Wavelength, that's our unknown. The question is asking what is the wavelength, so we're just going to write a question mark there. Okay, so we've got our triangle. We're going to cover up lambda because we don't know what that is, and we want to figure out what the wavelength is. So that's covered up. All that's left is S and F, so we're just going to write lambda equals S divided by F, or S over F. Lambda equals S over F. Okay, so then we're going to rewrite that equation right here. We're going to plug in for S and F. So S is 125, F is 25. So lambda just becomes 5. 125 divided by 25 equals 5. So then our answer, since we're looking for lambda, lambda is a wavelength. We measure our lengths in science in meters. So our final answer is going to be lambda equals 5 meters. Okay, what is the frequency? This is the final example. What is the frequency of a 3-meter wave that is traveling at 135 meters per second? Sorry about that. I noticed a little error that I had to fix before I went over this example. So the speed is going to be the first thing that we're looking for here. The speed is 135 meters per second. Frequency, that's our unknown, right? They're asking what the frequency is. So then lambda must be this 3 meters here. Now this is a little bit tricky because it doesn't say length or anything like that here, so how would you know that? Well, since it's measured in meters, that should tell you that it's a length. And so that's going to go in for our wavelength. Okay, so that's, we're going to write the formula. And again, we're looking for, what are we looking for? We're looking for frequency. So we're going to cover up frequency. And we're left with S and lambda. So frequency equals speed over wavelength. F equals S over lambda. Okay, so that's our formula. We're going to plug in the numbers. So in for S, we're going to put in 135. In for lambda, we're going to put in 3. 135 divided by 3 is 45, so our frequency is 45. we'll write our answer with units. Remember, frequency is measured in hertz. And if you're ever unsure of what the units are, just look at the table that you made at the top here. Frequency equals 45 hertz. Okay, so then what you're going to do here is try to solve the practice problems. There's 6 of them. You don't have to follow the steps that I do here. You do need to show some work, so you need to show me what you either multiplied or divided to get your final answer. And you also need to include units with your answers, so make sure that you're doing that. Okay, let me know if you have any questions. Thanks.